Genkit now officially supports Dart. This means you can now use Dart for full stack development. How awesome is that? You can build both the front end and the back end of your app in the language you love, which gives you more time to focus on features that your users love. However, there is one thing you should keep in mind. You need to secure your API endpoints to prevent them from being abused by malicious actors. Let's look at how you can create a Genkit flow and help secure your AI endpoints from potential abuse while still serving your legitimate users. I have an application that lets me try on clothes from a store before I consider purchasing them. I merely click virtual try on and the app loads my profile picture and has me virtually try on the product. Nice. Let's try setting up Genkit in this project. First, you need to create a new shelf project with the following command: dart create -t server -shelf vto-dart. This tells the Dart CLI to create a new shelf server from the shelf server template and place the code in a project called vto-dart. With this, you then add some dependencies to Genkit with shelf, and you're good to go designing your app. As a quick example, this is the skeleton of what a flow in Genkit would look like for a Dart server. You have an input and output schema to enforce typing. Then you initialize your Genkit plugins for the models you want to use. Finally, you define a flow that handles your business logic to transform product SKUs to images. I'm going to code this off screen and voila, backend is ready to go. But how do you know that this user is legitimate? Or even more importantly, that they are using your website to interact with your app rather than abusing your API endpoints to try on clothes from other retailers? To help secure this app from abuse, let's start looking at limiting requests from unknown devices. You can use Firebase App Check as a way to send limited use tokens to your Genkit backend. By sending a limited use token, you're saying that this token should only be available for 5 minutes. It can only be used once. In your Genkit backend, you can then add a handler using the shelf handler integration to extract the X Firebase App Check header and verify the token for its requests. You can also use the consume value to verify whether the token has been consumed before. This helps limit your token consumption to just clients that have embedded that request header to your request, and you rely on the device attestation provider you selected to verify that the device is legitimate. For Flutter developers, this means that you will likely be using reCAPTCHA Enterprise for web apps, Play Integrity for Android apps, and Apptest for iOS apps. You can even add a custom attestation provider if you want to support desktop applications. With App Check, you can help verify that the device is legitimate. But what about your users? You can use the same mechanism that you use for Firebase App Check, where you extract the authorization header and then verify that the user is one of your app users with a certain access level. For example, you may only want your premium tier users to have access to this feature, so you may have a separate function that assigns custom claims to the user. In your case, it may be something like is premium user equals true. When you get into the authorization token verification step, you don't need to perform any additional database reads. You could just look for that custom claim in the authorization header. If it exists, you can then move your user onto continuing to use your app. The user is now fully authorized and authenticated. With this shelf handler deployed, you're halfway towards limiting your users from abusing your quota. One extra precaution you could take is to store the number of requests your users made to your service in the last hour. In this virtual try-on app, if you wanted to limit the amount of times a user could request a virtual try-on to maybe 5 an hour, you could use a custom rate limiter that stores in a user collection each request and the time that it occurred. You can later query that collection to get a count of how many requests were made in the last hour using an aggregation query, which costs 1 read per 1,000 documents. This is perfect for this use case. With this approach, you can now limit your more enthusiastic users to a value that helps keep the cost at bay. But now you might be wondering, what happens if a user requests to try on an outfit that they had previously virtually tried on? Well, after each generate call, you can store the output in a bucket, so you have access to that image later. Then before you start your Genkit flow, you just check if that product already exists in the bucket. And if it does, return it. This caching helps save on cost by limiting the amount of requests that get to our AI endpoint for generation. This is great thus far. You have secured your Genkit endpoint from untrusted devices, verified users have the correct permissions, and limited the amount of requested generation calls in your Genkit flow that use existing product information. There is one more thing that you could do to secure your endpoint. and that is to reduce the risk of prompt injection. When I had originally implemented this Genkit flow, it was insecure in that I accepted 2 different URLs for generating the virtual try-on. The first URL I accepted was the profile photo for the user, which I read from their custom claim. The second photo URL I accepted was the product photo. Using these 2 items, I would construct my request to the Genkit endpoint. After demoing this to my colleagues, they were suddenly generating virtual try-on outfits for clothing items I did not even have listed on my website. So in this case, I modified my inputs to the Genkit endpoint to only take a product ID. This means that anytime a request came in, it would only have a virtual try-on request for that specific product. I then consult my Firestore database and my storage bucket to load the product information. It only loads the product image for the virtual try-on, nothing else. And if the product cannot be found, the request fails. With just a little bit of code, and thanks to Genkit's rich support for security, I was able to secure my virtual try-on endpoint. If you're using Genkit in your apps, I think you'll find that this approach is a perfect fit for you. I am Nohe, and I cannot wait to see what you secure next.